What is going on YouTube? Just helping you out here. And for today's video, I will be doing Chapter 12, Problem 43 in the Fundamentals of Physics textbook, 8th edition by Gerald Walker, Halliday, and Resnick. Chapter 12 is all about equilibrium and elasticity, and in Problem 43 we have a rod that's projected from a wall, we have a mass that is hanging from the end of it, and we are asked to find the shear stress and vertical deflection off the end of the rod. And so the first thing that I would like to do is just draw a little picture so I can refer back to it while doing the problem. And so we kind of have like a wall like that, we have our rod sticking out, and then we have, let's just say, a mass that's hanging on the end here. And so in part A, we are asked to find the shear stress, and so shear stress is equal to the force over the cross-sectional area. And so in this case, the force on the rod is the weight force of this block, which is equal to the mass of the block times gravity. And the area is the cross-sectional area of the rod, and in this case our rod is a tube. And so the cross-sectional area will be a circle, and the area of a circle is pi times r squared. And we have all these values, so we can just plug those right in. And so this is equal to 1200 kilograms times gravity, which is 9.8 meters per second squared, and all that over pi times our radius squared. And in this case, the problem statement, we are given a diameter of 4.8 centimeters, and so we know that our radius is half that, so our radius is 2.4 centimeters, and so we have 2.4 centimeters, but we have meters up here, so we need to convert this to meters as well. And so we know that there's 100 centimeters in 1 meter, and then if we square that whole quantity, and so if you plug that into your calculator, you should get that your shear stress is equal to 6.49 times 10 to the 6th newtons per meter squared. And so that's it for part A. And then in part B, we are asked to find the deflection of the rod. And so what that means is, as this mass is hanging down, this rod is going to bend down a little bit. And so if we were to draw a line from where this rod is bending back to here, and then find the distance between the origin here and that bending distance, that is the deflection of the rod. And so we can relate the shear stress of the rod to the deflection of the rod by F over A, which is our shear stress, is equal to G times delta X over L. In this case, G is our shear modulus, and delta X over L is our shearing strain, where delta X is the deflection that we are looking for, and L is the length of the rod. And so since we're looking for delta X, we can rearrange this equation for delta X by multiplying both sides by L and dividing both sides by G. And so delta X is equal to F times L over A times G. And so we just found F over A in the first part of the question, and so we can plug that right in. 6.49 times 10 to the 6th newtons per meter squared, and that's times L, which is 5.3 centimeters. And again, we have meters here, so we should probably convert our centimeters into meters. And so again, we know that 100 centimeters are in 1 meter. And then we can divide that by G, which we are given in the problem, which is 3 times 10 to the 10th newtons per meter squared. And so you see we have newtons per meter squared here, newtons per meter squared here. Those units cancel, our centimeters cancel, and we are left with just meters, which makes sense since this is a displacement. And so if you plug all that into your calculator, you should get that your deflection is equal to 1.15 times 10 to the negative 5th meters. And so that's about it for this problem. If you found this video helpful, please drop a like, leave a comment if you have a question or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.